So this next part is very important to ensure that there's no leaking of any of the buffer components during the fractionation. And that is assembly of the running chambers. You'll notice that there's a pink or red side and a black side. The red side is the anode side, the black side is the cathode side. And there's a clamping shoe which is asymmetrical. If you'll notice, on one side has an opening, which is the hinge point, and the other is closed. One thing on each of these chambers you want to be careful is not to ever touch this thin platinum wire inside the running chamber. So to assemble, grab each halves of the running chamber, place them on a surface, and bring them together like closing a book. Hold them from the bottom, not up here, so they stay together. And you'll notice there are two little tabs here. And these simply slide into that hinge region on the clamp shoe and bring it down. But don't push it all the way home. So the next step is I'm going to insert the dPC chip into the chamber. Again, remember there's a red anode side and a black cathode side. And now I'm going to use forceps to carefully remove the dPC chip from the water that we're incubating it in, grabbing the handle. I'm avoiding holding the plugs. You'll notice that it's bent in one direction, and this bent side will go over the red half of the running chamber. So simply slide this in and push down to seat it all the way to the bottom, and then click this down all the way down to the bottom of the shoe. To ensure that the chip is properly seated in the running chamber, look at the little loading ports. Make sure the top of the loading port is in line with the bend in the handle of the dPC chip. It should also look level as you go across. You should be able to not push it any further into the running chamber. Now ready to load the fractionator with the running chamber and chip. So I'll simply lift the lid. I'll take the chamber with the chip in it, and I'll just simply set it in to one of the running slots. And I will not push down on these two black areas. I'll simply gently push down on the middle to seat and seal the running chamber. One way to remember which side this should go in, the red side being to the left, is if you look at the front of the instrument, the anode side is also on the left. So keeping always the anode side on the left, cathode side on the right, just like the chambers. I'm now going to add the anode buffer to the anode side of the chamber by pipetting 600 microliters of it onto the red side. If bubbles form, that doesn't matter. They'll be removed during the run. And now I'm ready to load the next running chamber. I'm now ready to load my sample, which you'll remember is mixed into my cathode buffer, and that'll go on the black side of the chamber. 600 microliters. To know which program to run, you simply look at the top of the kit. For the pH 4.2 to 6.2 protein kit, you'll see a white 1, which would mean method 1. For the pH 6.00 to 8.00 protein kit, there's a green 2, so we'd use method 2. And for the 7.20 to 9.20 pH protein chip, we would use method 3, indicated by a blue 3. Currently all the peptide kits are run in manual mode, and so you have an orange M. I select the methods to run using each of these arrow buttons. So for each of the protein methods, I'd have a green 2, a blue 3, as I mentioned, an orange manual for the peptide kits. Since we're running the 4.2 to 6.2 kit, which has the white 1 method on it, I'll use the arrow keys to select method 1, and I simply push run stop. The instrument will download the program to the power supply, which you'll see down here, and then it'll begin rocking, and you'll see orange to red lights blinking on each of the chambers. These are monitoring each of the running conditions. Since we only have 2 chambers loaded, it's going to be looking for those 2 chambers. So you should wait to see that it recognizes both of those chambers. Take a minute or 2 to do that. You'll notice here that the voltage is slowly increasing, and we can see up here that the instrument has found both of the running chambers, and they show green, meaning they're running under normal conditions. Should there be an error, the light will turn red and the power to that unit will be turned off. Any ones that remain green will continue to run throughout the run, and the red ones will stop. This area here shows you roughly how far you are into the mode and gives you sort of a timing of that. You can also see how much time is left in your run by reading it off of the power supply. For method 1, this method takes 30 minutes, and so we'll wait until it has completed. So we've successfully completed our run. We know that because we have green lights at the end of the run. And now I'm ready to remove the chips from the fractionator. I use the black tabs to gently lift this out. And now I'm ready to remove the chip.